Welcome back. We're gonna start in on chapter 7. Chapter 7 is gonna be different integration methods. Seven point one is actually just a review. Well, most of it's a review of stuff you should know. Now, if you walk in after I said grab a handout, they're up here. You should have 1 through 12 memorized. 13 and 14 you don't need memorized because it's easier like doing tangent u, doing sine u over cosine u, and doing a u sub on the denominator. Same thing with cotangent. The hyperbolics, I'd say memorize them, but they're the same thing as the non-hyperbolic trig functions, except there's no negative signs. So like you have the same formulas memorized. 21, 22, and 23, they're kind of in 7.4. We start doing inverse trig functions and working with them there. But they're going to pop up today in today's lecture as well. So I thought I'd have some of them listed down. And a quick example of one that I see here, like the tangent one. Yeah, I'm going to do the generic one with 1 over 1 plus x squared. We can always look at knowing the derivative of the inverse by just taking the derivative of this. If we take the derivative of this, here the d dx and the integral with respect to dx cancel. And the left side is just 1 over 1 plus x squared. And so if you're looking for, and the derivative of a constant is not necessary, so this is the derivative of tangent inverse. So if you need to know the derivative, just take the derivative of both sides of that equation. Seven point two begins what I like to call fun shit. 7.2 is fun time. Integration by parts. You know how it knows how a lot of stuff we've done with integration is like reversing what we did with derivatives. Hopefully you've seen that, notice that with the integrating stuff. There's something we haven't done the reverse of yet. We have not done the reverse of the chain or the product rule yet. So this integration by parts is a technique. It's the reversal of the product rule. So let's say we've got f of x times g of x. And we take the derivative of both sides of that. Or we take the derivative of that. And we notice that we got f prime of x times g of x plus f of x times g prime of x. That's the original product rule. Just like I was saying, we can undo the integration by doing the derivative. We can undo the derivative by doing integration. So if I integrate both sides here with respect to dx, the left side just goes back to f of x, g of x. And I am gonna break this right side up into two integrals. We're gonna have f prime of x times g of x dx plus the integral of f of x times g prime of x dx. To make this a little clearer on what we're going to do, I'm going to say we're going to let u equal f of x. And we're going to let b equal g of x. So if I take du, this is f prime of x dx. And we do the derivative with respect to x here. On b, we've got dv equals g prime of x dx. So I'm going to plug that shit back in. I'm going to plug these things end up here. And I have u times v equals the integral g of x is v and f prime of x is du. So I've got b du plus f of x was u and g prime of x dx was dv. Then you get the formula by subtracting the integral of v du from both sides. And we get the integral of u dv equals uv minus the integral of v du. This is integration by parts. The way you should memorize. This isn't actually undoing well, we are undoing the product rule, but it's not a way to directly like have a product rule and then go backwards. You will eventually have something like the right side. And if it's set up right, if you're taking the right class, like differential equations, you'll figure out how to go from this to this directly. But it requires identifying some magic shit there. That's another class. This is something we can use when we've got weird shit going on. I think the best way to illustrate this is with an example, though. Does anyone need this up longer? Yeah, I see pencils doing. So what this kind of does is it converts an integral to another form. And hopefully easier. But not always the case. And in the first one, I'm going to walk you through the 4 different ways we can use this thing. All right. So let's give you guys an example and we'll start there. we want to integrate x sine x dx. So the steps in this is separate this into a u and a dv. So option 1, I can let u equal sine x, and I can let dv equal x dx. And the other common way that you'll look at it is doing u equals x and dv equals sine x dx. Options 3 and 4 are ones that happen sometimes. 4 never happens. But I'll show 3 real quick. 3 is setting u to equal everything you see, x times sine x, and then letting dv equal dx. This is one it's easily forgotten, but very useful. In some setups, some integrations. And the fourth option, it is technically an option, but you would never use it. Saying u equals 1 and dv equals x sine x dx, because this is completely unhelpful. This is what we started with, and so it's not helping, right? But let's take a look at what the 3 options that we have. And then we'll talk about how you pick which way is the best way to go. So, and as a reminder, let's put our formula at the top of the screen. We will do the integral of u dv equals uv minus the integral of v du. That's what we're working with. So we need those elements. So if I have, it looks like I need a du and I need a v. I can get du from u by taking the derivative, right? So du is going to be cosine x dx. We find v by integrating dv. So v is going to equal 1/2 x squared. So we can rewrite the integral of x sine x dx equals u times v. I'm going to put the v first. 1/2 x squared sine x minus the integral of v, which is 1/2 x squared, times du, which is cosine x dx. So this is v times u minus the integral of u dv. Now, that looks like I have an even uglier integral to work with, right? In fact, the exponent has gotten bigger, and it looks like this is a bad choice. I would argue that this is the wrong way. So it ends up being a bad choice. But while we're walking through the ways to do them, it's worth seeing all your options. Here on number 2, we can say du equals the derivative of x, which is just going to be 1 dx. And if we integrate dv, we get v equals, sine came from cosine, but cosine's derivative is negative. So this is, negative cosine x. So my integral of x sine x here, dx, we want u times v, negative x cosine x, minus the integral of v, which is negative cosine x, v du, which is just 1 dx. Well, that's negative x cosine x. The minuses cancel. I just have the integral of cosine x dx, right? So we could finish that one. This will give us our answer. We finish integrating, we get negative x cosine x plus sine x plus c. I was waiting to see if anyone was going to pull it forward. I don't know if you heard my tone. It didn't sound like the sentence was ended yet. So that's the answer. On this one, we would have to do the product rule on x sine x. So we take the derivative of this, the derivative of the first times the second, plus the second times the derivative. Wait. Said that wrong. But that's what it is. And v equals x. So this isn't going to help also. You'll see when we got uv, it's fairly simple. But it's that minus the integral of b du that just got worse. So this is a bad choice. Yeah. Yeah. You get a second to finish writing all that good juicy stuff down. You guys ready for some more? Okay, so I said there was 3 viable options. A good way to pick u. It goes by Liat or Liate. Let u be the first one on the Liate list. L stands for logarithmic functions. I is for inverse trig functions. A is for algebraic functions. And this includes polynomials. T is for trig functions. Trigonometric. Any idea what E would be for? Exponentials. Yeah, that's the last one we haven't talked about yet. This is usually most of the time what you want to do. Every once in a while, you'll find out that doesn't work the way you like, but it's a good starting point. So obviously the LIATE comes from the initials. It's an acronym form. So for our next example, we will do the integral of x squared e to the, let's go e to the 3x dx. So I have an algebraic one here at the x squared, and I have an exponential there with the e to the 3x. So algebraic comes before exponential. We're gonna let u equal x squared. So that du equals 2x dx. And we'll let dv equal e to the 3x dx. So u dv. And if I integrate e to the 3x, what do I get? We get 1/3 e to the 3x. So we have x squared e to the 3x dx equals, we want to do uv x squared times 1/3 e to the 3x. I'll put the 1/3 first. And then we want minus the integral of b du. So 1/3 e to the 3x times 2x dx. I think I'll move the 2/3 outside. And we have x e to the 3x dx. Again, not easy to integrate as is, so we can do integration by parts again. So let's do it again. I'll call it like, I'll say U2 and DV2, if that helps distinguish for you guys. U2 is going to equal X, and DV2 is actually our old V, e to the 3x dx. So du2 equals dx. And b is gonna equal 130 to the 3x again. Now, there's gonna be frequently times where you gotta do it twice. And you're gonna wanna be lazy on the second round. I strongly recommend you put that shit in parentheses. I have minus 2/3, I'm gonna use brackets. Because the minus 2/3 has gotta hit both the UV and the VDU. It's gotta hit both. And if you don't put it in parentheses, you may not remember to distribute to the second one. UV is 1/3 x e to the 3x. Then we have minus the integral of v du, which is just 1/3 e to the 3x dx. And now finally, there's something we can integrate. So x squared, or integral of x squared e to the 3x dx equals, we've got 1/3 x squared e to the 3x. If I distribute the 2/3, I've got minus 2/9 x e to the 3x. And then I've got plus 2/9 doing the 2/3 times the 1/3 integral of e to the 3x dx. I'm making, you could probably skip this step with practice. I'm making sure I write down that I was just distributing here. And so we have 1/3 x squared e to the 3x minus 2/9 x e to the 3x. This is going to produce another 1/3 e to the 3x, which gives us plus 2/27 e to the 3x, plus a constant. And that is our left side, what we started with. Good. This becomes a really handy tool for integrating throughout Calc 2 and Calc 3, really. Integration by parts is one of my favorites. I also like partial fraction decomposition. That's probably my favorite. But it's actually based on an algebra topic that a lot of algebra teachers get. So you probably haven't seen the actual decomposition part is an algebra thing. I'll show it to you later though. All right, ready for more? Let's do the integral of the natural log of x dx. Yep, that's it. That is it. You want to look at it and go, that seems too simple, but do you know how to integrate that? No, we know how to take derivatives of natural logs, but we don't know how to integrate natural log. So we're going to follow the Liotte again. I'm going to write the UV minus VDU again. Just so we have it up there as a reminder. By going down Liotte, we have a log. So I'm going to make my U equal natural log of x. And I'm going to make my dv equal dx. So when I take the derivative, we get 1 over x dx. And we integrate here, we get x. So we do u dv or uv minus v du. The integral of the natural log of x dx turns into u times v is x times natural log of x minus the integral of v du, x times 1 over x dx. That's just the integral of 1, right? So we're going to get x natural log of x minus x plus c. Let's let you guys do one. So Ainsley, what were the 3 points you missed from? I figured it's kind of hard to lose just a couple points from a calculus blunder. Are you going to tell Stephanie that she gives away too much extra credit too? No? Probably not. I hear she's a pretty laid back, fun teacher. What'd you guys use for u? What? Natural log x. Okay, and that means dv has got to be x squared dx. That's a good choice. That's following Liotte. So du is going to be 1 over x dx. And b is going to equal 1/3 x cubed. So when I integrate x squared natural log of x dx, I get u times v, 1/3 x cubed natural log of x, minus the integral of b du, 1/3 x cubed times 1 over x dx. And this portion looks like the integral of 1/3 x squared dx. I'm gonna clean it up. So our integral, when we finish it out, 1/3 x cubed natural log of x. We're doing minus the integral of that, up a power, divide by the power, and there's a minus sign up front. 1/3, basically times 1/3 is 1/9 x cubed plus a constant. Let's throw in one of those shitty inverse functions. Let's do the integral of tangent inverse of x dx. So we're going to let u equal the inverse function. And dv equals dx. So that v equals x is pretty easy. If you go back to the first page, you will have seen that this is 1 over 1 plus x squared. Yeah. Thank you. So our integral is u times v, x tan inverse of x, minus the integral of b du. I'm going to put the x on top, x over 1 plus x squared dx. Now what? This is a u sub, right? This is not a by parts thing. We'll let u equal 1 plus x squared, so that du equals 2x dx, or 1/2 du equals x dx. So we have x tangent inverse of x minus, we got a 1/2, I'm gonna put the 1/2 out front. The x and the dx are eaten up by the du. And it looks like we just got the integral of 1 over u du. So we integrate. Integral of tangent x dx equals x tangent inverse of x. What does 1 over u integrate to? Natural log of u, right? minus natural log of u plus, I need a 1/2 there, plus c. But we didn't start with u, we're not gonna end with u, and it's that u. So our final answer on this one. X tan inverse x minus 1/2 the natural log of 1 plus x squared plus c. And at this point, I probably don't need absolute values anymore because both 1 and x squared are positive. So there's no way the inside's negative. But I'm gonna leave it there because I want to write it again. Are you guys ready for the fun time? I said it's fun time, but we haven't gotten to fun time yet. This is just mediocre enjoyment time. You know, like someone starts to give you a massage and you're like, this could be a glorious massage or this could be like a dirty trick and I'm just gonna like be left hanging. No, let's get the full-blown massage going on. Let's have some fun. You guys ready? Does anyone need this up longer? Oh, yeah, there it is, right there. E to the x. Fuck. E to the x sine x dx. Yeah. Oh man, what? What? Okay. So first thing that shows up here on Liate is trig function. We will let u equal sine x and dv equals e to the x dx. So du equals cosine x dx and v equals e to the x. If I do uv of e to the x sine x minus the integral of v du. V du is e to the x cosine x dx. And you're like, MFer, that don't look like that helps, right? Let's keep going. Let's do a U2 and a V2, dV2. Let's make U2 equal cosine x now. And dV2 equals e to the x dx. So that we get du2 is negative sine x dx. And v equals e to the x. And I have a minus, so I'm going to put this in parentheses. We're doing U2 V2 e to the x cosine x minus the integral of v du, which is e to the x negative sine x dx. So that's my UV minus VDU. Let's clean it up a little bit and see what we got. I've got, for this integral, I've got a minus, and a third minus. So 3 minuses is still negative. E to the x sine x dx. Fuck. That, how's that fucking help? We are back to where we started, isn't it? No, we're actually at the end. Yes, because now we can do some algebra. Let's add the integral of e to the x sine x dx to both sides. And this is why you've noticed I keep writing down the left side, because a lot of students just fucking don't. And they just do the UV minus VDU to put the answer in a box. But sometimes we need that thing we started with. Now I have 2 of those integrals. And I can factor, I'm going to factor out the e to the x on this. I've got sine x minus cosine x on the right side. It's like fucking magic right here. You're like, it got worse, it got worse. Wait a second. No, it got me right what I wanted. How do I get what I want here? Divide by 2 or multiply by 1/2. And it's a done deal. Integral of e to the x sine x dx is 1/2 e to the x sine x minus cosine x. Or you can have the 1/2 e to the x on both of them. Plus c. Was that not cool? Was that not fun time like I promised? I don't see enough impressed people here. I think that's just really cool. All right, let's take a 10-minute break. I think it's 5 o'clock. Yep. Let me pause this video. All right, let's do another one. Oh, let's add some excitement to it. Doesn't that sound like fun, Dad? Add some excitement. That wasn't a sincere smile. That looked like very forced. I don't know if I like that. Limits of fucking integration. What? Either. Oh, hell no. The fuck are you doing to us, Mr. Jones? Now, I don't know that this is going to get, yeah, go for it.
It's like a big
Not really. Let's start off by rewriting that sine of 2t. I don't like having sine and cosine and having different values. So 0 to pi e to the cosine of t. Sine of 2t, the formula for that is 2 sine t cosine t. That's my sine of 2t. And then we have a dt. And I'm going to do a u sub here. U equals cosine of t. Let's say w. We use u and v in integration by parts. We'll do a w sub. W equals cosine of t. So dW is negative sine t dt. Or we make the dW negative and that positive. And that will eat up the sine t and the cos dt. I still got a 2 that goes out front. I'm going to put the -2 out front. And now I've got W e to the W dW. We do new limits. What is it when t equals 0, W equals 1. And when t equals pi, W equals -1. You don't have to do this step. Keep in mind, we can get rid of this negative by flipping this integral and putting -1 back on the bottom where it should be. We could do this as -1 to 1 W e to the W dW. But assuming you don't recognize that or forget that, I'm not going to do it. But it still should give us the same answer. Same answer. Now we'll do our U subs. We'll do U as W. And e to the W dW will be our dV. So we have our -2. UV is W e to the W from -1 to 1. Minus the integral of B du. -1 to, I got these backwards. 1 to -1, there we go. B to the W dW. So if I finish integrating, we have minus e to the W from 1 to -1. Now here I waited, but you don't have to wait to do the 1 and -1. Like we could have evaluated, we could do this right away. And like when the problem gets long, sometimes you want it because it cleans, makes it so it takes up less fucking space on your paper. But what do we get? We got -2 times, we'll do the upper one, -1 e to the -1 minus 1 e to the 1. And then I've got minus e to the -1 minus e to the 1. So this becomes negative e to the -1 and positive e to the -1. Hold on a second. Yeah, that's right. It looks like the e to the, sorry, positive one right there. It looks like these two cancel out. And I just have -2 times negative e to the -1 minus e to the negative 1. Which ends up, when we combine everything together, negative 4 e to the negative 1. Or negative 4 over e. Did I go too fast on something? Nope. Minus 1 e to the 1. Should what be positive?
Because it's negative on the outside and negative on the side. So
All right, you're right. Excellent. I did go too fast. All right. So that's how we do it with limits of integration. You can do them right away as you're going through them. You don't have to, you can save them all to the end, but it is handy to write them down as you're going. Make sure that you don't drop the limits there. What about cosine of natural log of x dx? Dun, dun, dun. What? We could, but then it's going to generate a 1 over x, and it is a viable choice. But it turns out to be faster to not. And we'll look at the use of approach second. Actually, fuck it, let's do it now. What did you want to use of here?
I would just like.
All right, I'm gonna say W because we're gonna use U later. So W equals ln of x. So dW equals 1 over x dx. And I don't have an x, so I need to do something with it. I've got clear the fraction, I got x dW. What is x from this? X, if we raise both sides to an e, I've got x equals e to the w. So I could say this is e to the w dw equals dx. And that would rewrite this integral as cosine of w e to the w dw. No, in fact, we did, but we did one just like this earlier. We did e to the w sine w, or e to the x sine x. I guess now we'll see how much this changes it.
You still have to end up doing the.
We're gonna have to do it twice like we did before. So I'm gonna say u equals, it's the first one on the list, which is a trig function. Cosine of w dv equals e to the w dw. So du is negative sine w dw. And v is e to the w. We've got uv is e to the w cosine w. Minus the integral of b du. There's two minuses, so it's going to turn into a plus. E to the w sine of w dw. Do this again. U2 is sine w. So du2 equals cosine of w dw. And we can reuse v. Let's reuse v. Let's not write it down again. Since we're doing the same one, let's reuse v. uv is e to the w sine w. Minus v du is e to the w cosine w dw. So we can add this to both sides. And we get two of them. And I'm going to factor out the e to the w on the right. So we have our integral. Cosine of w was cosine ln of x. And the e to the w dw was dx. So that's the integral we started with. Equals 1/2. E to the w is e to the natural log of x. Then we have cosine natural log of x. It's just parentheses. Plus sine of natural log of x. And that only cleans up a little tiny wee bit. What cleans up here?
Yeah, it's also root e to the ln x becomes x.
E to the ln of x just becomes x. Yeah. Plus c. We did not have limits here, so we got to have our constant integration. You guys ready for one that's a little unintuitive? The integral of sine cubed x dx. So what I'm going to do is I'm going to make u equals sine squared x and dv equals sine x dx. later on in this chapter, we'll learn another way of doing this. So du is 2 sine x. Then the derivative of sine x is cosine x dx. And v is just negative cosine x. This equals uv, so negative cosine x sine squared x. That's my uv. And then minus the integral of v, negative cosine x du, which is 2 sine x cosine x dx. Oh, I didn't go back and show you the other way to do the other problem. We'll do that in a little bit. So I've got negative cosine x sine squared x. This becomes a positive, and I'll pull the 2 out. And it looks like I've got sine x cosine squared x dx. Now what? This integral isn't too bad. It looks bad, but it's not bad. Because we can say, just do u sub. U equals cosine x. So du equals negative sine x dx. Or negative du equals positive sine x dx. And this becomes, we still have that first part, plus 2. I need a negative now. So I'm going to replace that plus with a negative there. And we've just got u squared du. So the integral of sine cubed x dx is negative cosine x sine squared x plus 2/3 u cubed plus c. But we didn't start with u, and it's not going to end with u. U was cosine, so we got cosine cubed x here. Oh, and that was a minus. So we get minus. I'm going to go back and look at that cosine natural log of x real quick. So the outer function here is cosine. That's what we're just gonna say u equals cosine natural log of x, and dv equals dx. I agree. My inclination was to do a substitution first, but this actually turns out to work. We take the derivative, and this is negative sine ln of x Then we gotta do the chain rule, so the derivative of ln of x is 1 over x dx. And b equals x. We have x cosine natural log of x minus our integral of b du. And you'll see the x and the 1 over x cancel out. So that is really minus the integral, or plus, because there's two minuses, sine natural log of x dx. And we do it again. U equals sine natural log of x. And dv will remain the same. Cosine natural log of x. The derivative of the inside is 1 over x and then a dx. And b equals x. And thankfully, there's no minus to distribute, so I can just put it in without parentheses. UV is x sine natural log of x minus the integral of v du. You're going to see we get our cosine x, or cosine natural log of x again. Because the x and 1 over x are going to cancel. And we add that to both sides. I factored out this x here. I don't know that that helped since I had to add in fucking parentheses. I don't think I made it any shorter by doing that. We'll have our plus c. We multiply by the 1/2 on both sides. And we get what we had before. You will find like the U sub approach is doable, what we did with the W. But if we have something like cosine natural log of like 5x, this method is easier. Just so you don't fuck up with the 5 throws a hiccup in things, but when you're working with it, it doesn't really do it so much here. If you do it, if you don't use the switch to W, you can keep track of it fairly easy. How do I know? Because not this Saturday, but the previous Saturday, I was helping a student that's taking Calc 2, like an online class somewhere else, and they're using a different book, and they were already on this. And she was doing sine natural log of 8x. And we did the U sub and we got that motherfucker wrong. And it was because of that fucking number inside. And I was madder than shit. Cause I should have recognized it. It's easy to fuck it up. But doing this method doesn't fuck it up. All right, you ready for another? All right, we having fun, Brett?
Oh,
That's the right answer. That's the good spirit. Is it as much fun as water polo? What's the correct answer? No, comment. You're supposed, the correct, what's the correct answer, everybody? It's,
Hey,
it's more fun than water polo is the correct answer.
It's so much.
Jesus.
Water polo is so much fun.
Well, if you're not having fun, maybe the next one will be more fun for you.
No, it's plenty of fun. Water polo is just like.
No, it's already too late. He sees no comments, so like, that doesn't sound like he's having enough fun. I wanna up the fun level.
Water polo is best sport in the
Let's up the fun level.
world.
I don't know that I'd be any good at water polo. Wait, do they have a goalie in water polo?
Yes.
I make a good block. I'm a giant wall. And I float, so like I'm like gonna be bobbing in the water. All right, let's do 0 to 2. Natural log of x squared plus 1 dx. Now a U sub here is gonna take us down another row where we don't have an x showing up, so we'll have to do some crazy shit and it's not worth doing. Let's just say u equals ln of x squared plus 1. And dv equals dx. So v equals x. du is derivative of the natural log is 1 over the inside times the derivative of the inside times dx. So this becomes uv, which is x natural log of x squared plus 1, evaluated from 0 to 2, minus the integral of v du. I have an x here, I have an x there. I've got 2x squared over x squared plus 1 dx. I'm gonna move that 2 to the outside real quick. It's a constant, we can pull that out of an integral. What do you guys want to do? There's 2 ways to advance from here. I'm going to do both. Let's start with the one you're never going to recognize. That way you see it and go, maybe it'll pop up in your brain. Well, first off, let's evaluate this so we're not dealing with it a bunch. We've got 2 natural log of 5 minus 0. So that part's easy. So we've got 2 natural log of 5. I'm going to have minus the 2. What I'm going to do is I'm going to add 1 and subtract 1 from the top. Oh, and we still have our limits of integration 0 to 2. So 2 natural log of 5. What we're going to do at this point is we're going to split it up. X squared plus 1 over x squared plus 1 dx. And then I'm gonna distribute the -2 to this -1. We've got +2 over 1 over x squared plus 1 dx. This was a minus out here and a minus here, but the two minuses make this plus right here. That's just dx now. So we integrate this, we get 2 times the natural log of 5 minus 2x evaluated from 2 to 0. This is actually tangent inverse. That was on our list. Yeah, this one I split up into x squared plus 1. And I moved the -1 to another fraction. I took, that's why I added the 1 and subtracted 1. Does that make sense? We do that with fractions. We can do that with, when we got addition or subtraction on top, we can split it into separate fractions. Like I said, this is not your intuitive way. This just ends up being 2 natural log of 5. Minus 2 times 2 is -4. Plus 2 tangent inverse of 2 minus 2 tangent inverse of 0. I believe this one is 0, I think. But either way, that's what it is.
Yeah.
The other way, I don't think this one, because what we're saying, what you're doing is going theta equals tangent inverse of whatever the argument is, like the 2. So 2 equals tangent theta. And I don't know where tangent theta equals 2, so I'm just not even gonna fuck with it. The other way of doing it, let's bring that line down above. Option 2. I'm gonna leave the 2 natural log of 5 in. And start back at this line real quick here. I'm gonna let u equal the bottom. It's always worth a try. So du equals 2x dx. I don't know if this is gonna help. We're about to find out. The more I'm looking at it, I don't know that it does. So 2 natural log of 5. I only have 1 x here, so I need to solve this for x. X equals, if I subtract 1 and take the square root, I got u minus 1. And I use this 2 with this dx for that. And so it looks like I've got 0 to 2. I don't want to put the limits in yet. I'll look at the limits in a second. We have square root of u minus 1 over u du. I don't know that that helped. That didn't help, did it? That looked like it helps to me. So maybe that didn't help. I thought it was. It's always worth checking. This doesn't look any better. All right, you ready to tie it into something we did before? What? A Link to the Past? No, not a Zelda game. Let's see. Let's find the volume of the solid. Oh, really? Fuck off, Jones. Find the volume of the solid generated. By revolving the region. Between y equals sine x. And y equals 0. From 0 is less than or equal to x, less than or equal to pi. Around the y-axis. So I'm going to draw my picture. That's y equals sine x. So if we revolve it around the y-axis, we have two options. Disk washer is going to do something like this. So we're going to have an outer radius minus an inner radius. And outer R is inner R, so this isn't going to work. Disk washer won't work. So let's do cylindrical shells. So the width of this is a dx. And when we did cylindrical shells, it was 2 pi r h. So going out to this block here, the radius is actually just x. And it looks like the height is y, which equals sine x. Oh, well, there's a dr in there as well. And in this case, dr is dx. So we have, and we're going from 0 to pi on this. So we've got 0 to pi, 2 pi, r is x, h is sine x, dx. And I'll move the 2 pi outside so it doesn't distract us. So we have an algebra and a trig. So we're going to let u equal x. So du equals dx. And that means we're gonna use dB equals sine of x dx. So that v is negative cosine x. We have negative u times v is negative x cosine x. Evaluated from 0 to pi. Minus the integral of v du. So that becomes a plus. And we have 2 pi times negative x cosine x from 0 to pi. And we integrate cosine, we get sine. And a lot of these are 0. I have negative pi cosine pi minus 0 cosine 0 plus sine pi minus sine 0. That's 0, that's 0, that's 0. And cosine pi is negative 1. So this is 2 pi times pi, we just have 2 pi squared. Wasn't that fun? It may not be more fun than water polo, but it's got to be better than frisbee golf. Frisbee golf, you just run around throwing a fucking frisbee. That is not that fun. Unless you're drinking, then it's fun. Any questions? That's all I got for you. Get the fuck out. That was plenty of example problems. If you don't know, try to use the Liotte thing to figure out what to use for you. If it doesn't look like it's working right away, try doing it one more time. Very rarely do you need to do more than twice. Unless you have like x cubed times cosine, then you keep making u the x term and it keeps going down by 1. And then if your first try doesn't work, try changing up. Don't just assume it doesn't work. Try changing up what you gave to u and dv.